in the last video we designed this neural model. So it's a neuron core with the registers and the counters. Now we're gonna create a test bench for this file here. So the first thing what we need to do now is to create a new Verilog file and save it as test bench neuron. So what we can do now, it is, since this has same functionality as neuron core, so we can reuse part of the code of the test bench for the neuron core. So let us open the neuron core here, test bench. And copy all of it, place it here, and then now we need to make some change. So our test bench file, it's test bench neuron. So and our model is neuron, so not neuron core. And then the inputs that we have here, start clock, e count. So we need to make start. It is capital letter. Yeah. Start, test bench, start. And then we have clock. And then it's test bench clock. And then we have e and count. So count, it is the last one. And then it's count, so it is capital letter count. And then we need to declare the clock and count. So reg test bench and clock. And then we need to declare count too. So count is an output, so wire. And this is 3-bit. Count is 4-bit. So we need to have count. So, and then next we can declare our clock. So we can have here always begin and we can have a clock with the 4 nanosecond period. So this one will generate a clock with 4 nanosecond period. And then next, what we can do now, what we want to do here, we can generate the, so we don't need all the, we couldn't have the corner cases, but now I don't prefer to have these corner cases. We can just create a random test. So this random, it will do the job. And then we can just create 5 inputs of it. It is okay to create 5. So what we need to do here, when we generate those 5 inputs, because we know our module here, it have a register, so we need to create those values when they are on the registers. So we're going to use them, and then this will happen after 2 o'clock. So you will see on the result of it's 2 o'clock. So we need to generate each random number after 2 clock pulse. So at positive age, so 2 times after 2 o'clock we generate random X and Y. And then what we need to do next is to test the operation. And then here now we don't need to delay it for 95 nanoseconds, because now we are dealing with clock. And then we know that our clock will happen after 2 clocks. So we need to delay it for 2 clocks too. But here now we'll delay it at 2 o'clock again, but now we need to make it at negative age pulse. So when we delay at the first clock, we need to reset the registers to 0. So we need to initialize them. So we need to, for example, to make the start to be high in the first clock, and then in the second clock we need to make it off so we can take the changes. So, and then we will see that on the model sim how it will look like. In the first clock we reset our registers, and then the second clock we don't reset them, so we already initialized them, and it will start to take the values. And then here we need to make those tests. So the test is similar, but here we need to make a 5 because we just create 5 random inputs. And then when we are displaying the X values here, it will display the values of now one. So we need to display the previous value because we have delayed it. So what we can say, we can declare, for example, x1, you can call x1 early, and we need to set is equal to x1, and then we need to do for all of the x's. So you can say x2, and for w, so w1, and w2, and then we need to change this one. So the reason that we are doing this, because it will not display the same values. So this is w1, and then we have x2, and then we have W2. After we have done that, and then we need to delay this for 2 clock. Since we have already delayed it here in 2 clock, so we need to have this delay here and delay our display for 2 clocks. Now we can test it now, and then we have this expected value. So, and then we don't need to delay it with 100 nanoseconds, since now we are using clock. And then what we can do next is to declare these values here. So we can declare them here. It is 3 bits, so we can have x1 and x2, and then we can have w1, then we can have w2, and then we need to initialize them to 0, 2, so we can, for example, do it down here. We can set equal to 0, x2, x2 and w2. So okay, x1 to w2. So that is, it's kind of our idea how we want to test it. Is just similar as Neuron Core, but now we have introduced the clock and we have our registers. So let's save this one here now and try to analyze and synthesize to see if we have done everything correctly. We see now we have some errors here. So let's look what kind of error is this one. Is line 21. So if we go to line 21, okay, we see it's the neural model here. Let me check. So we have start clock, access, small letters. Okay, so it should be small x, small letters, x and w. And then this parenthesis here should be there, it should be here. And save it and try to analyze and synthesize again. So on the next video, we will try to simulate this on the model sim.